Okay, see, read the problem carefully. That is, a shunt generator delivers a 195 ampere at a terminal voltage or the terminal potential difference of 250 volt. That means according to write down the given data. So we will write the given data here. Given data. So load current is given. IL is equals to 195 ampere. Terminal voltage or the potential difference across a terminal, it can be given 250 volt. The armature resistance and shunt field resistance are given. That is RA is equals to 0.02 ohm and RSH shunt field resistance, it is equals to RSH, it is equals to 50 ohm, right? Then the iron and frictional losses is equals to 950 watt. Iron and friction losses which are comes under constant losses. So we are writing here constant losses or iron and friction losses. Iron and friction loss, it is equals to 950 watt. Find first one, we want to find the EMF generated. That is easy, we want to calculate. Second one is nothing but copper loss, so PCU we want to calculate. Again third one, it is nothing but output of the prime mover. Output of the prime mover means what? Output of prime mover, it is nothing but input of the generator. Generator is input asset. And then find out the efficiency, that is commercial efficiency, then mechanical efficiency and electrical efficiency. So this quantity we want to find out by using this example, and after that we want to find out the efficiency. So we have discussed regarding power stages. So generator converts mechanical energy into an electrical energy. That is input to the generator, it is nothing but output of the prime mover. Prime mover जे output असेल, it is nothing but generator input. Okay, and there are some constant losses is there. After that there is a mechanical power developed. Then there are copper losses, and after that the actual output of the generator or electrical output of the generator. See, I will draw the diagram here for better understanding. I will draw here a diagram. This is the field winding. This one is the armature of the DC generator, and here it is load. It can be connected. Load connect here. So here it is load. See, terminal voltage is given. It is nothing but 250. Load current of the generator, it is nothing but 195 ampere. Armature resistance is given 0.02 ohm. Shunt field winding resistance 50 ohm. This is the IA, and this one is the ISH. Okay. So see, we want to calculate the copper losses. आपल्याला copper losses calculate केली की total losses मिळतील. Once we calculate the total losses, then we are able to calculate the input of the prime mover. See, the load current is given, IL is given, terminal voltage V is given. So according to this, we are able to calculate the power output, P out of the generator. सांगा फॉर्म्युला काय? आउटपुट पॉवरचा फॉर्म्युला. आउटपुट पॉवरचा फॉर्म्युला. फॉर्म्युला ऑफ आउटपुट पॉवर P आउट. पॉवरचा फॉर्म्युला काय? VI. So output terminal voltage is given and the load current is given. That means V into load current IL. So V is nothing but 250 into IL is nothing but 195. किती येते power? P out is equals to 250 into 195.
48,750.
750. Okay, it is in watt. 48,750 watt. So output power we people know. Now see, we want to calculate first one EMF, that is induced EMF or EMF generator. Which formula I will use here? EZ is equals to कोणता फॉर्म्युला यूज करू शकतो इथं? Generated EMF formula. Which one?
V plus IR plus
Okay, so there are two formula. One voltage equation is there and one of the generated equation is there, or the generated EMF equation is there. So EG is equals to 5P and Z divided by 60A, but we are not having the value of 5P N or Z. Okay, so we are using the voltage equation of DC shunt generator. EG is equals to terminal voltage V plus the armature drop, that is IARA. Okay, see, we are having the value of V, we are having the value of RA, whether we are having the value of IA. IA ची value आहे का आपल्याकडे? See, this much IA.
Okay.
So see, if we use here KCL equation, the equation becomes IL is equals to IA minus ISH, or IA is equals to IL plus ISH, right? IL plus ISH. So we are having the value of IL. IL ची value आहे आपल्याकडे load current ची.
Yes, sir.
Yes. So we are having the value of ISH. हा करंट आहे का आपल्याकडे? So we are calculating this one, that is ISH is equals to terminal voltage V divided by resistance. According to Ohm's law, I is equals to V divided by R. So V is nothing but terminal voltage. RSH is nothing but shunt field winding resistance. So terminal voltage 250 divided by resistance, it is nothing but 50. So according to this, ISH
5 ampere.
5 ampere. Okay. See, according to we are able to calculate the IA. याच्यावरून आपण IA calculate करू शकतो. That is IL is nothing but 195 plus armature shunt field current ISH is equals to 5 ampere. So armature current IA, it is equals to 250. 200, no? IA is equals to 200 ampere. Now we are able to calculate the EG. So EG, it is equals to terminal voltage 250 plus IA 200 into RA. What is RA? 0.02. Tell me the value of EG. Hmm.
254.
254 volt. Right. So EG is equals to 254 volt. Okay. We have calculated first one point is nothing but EMF generated, that is EG is equals to 254 volt. Now second one we want to calculate, that is copper loss. What is the formula for finding copper loss?
I square into RA.
I square into RA. So see, there are shunt field winding is there. So shunt field winding having and some of the resistance, armature winding having and some of the resistance. So there are two copper losses, that is armature copper loss. First one is armature copper loss. Formula for that is nothing but IA square RA, and shunt field winding copper loss. Shunt field copper loss. Okay. Shunt field copper loss, again formula for that is nothing but ISH square into RSH. So put the value IA square 200 square into RA is nothing but 0.02. 0.02 किती येत आहेत आर्मेचर कॉपर लॉस?
800.
800. Okay, so armature copper loss is nothing but 800 watt. Similarly, shunt field winding copper loss, that is PCU of shunt field winding, it is equals to ISH square 5 ampere square into RSH. RSH is nothing but 50. किती येते?
1250.
1250 watt. So total copper loss is nothing but sum of these two losses, that is copper loss of armature copper loss plus shunt field winding copper loss. So armature copper loss 800 plus shunt field winding copper loss 1250. So total copper loss or the PCU, it is equals to किती येते हे? 2050 no, 2050 watt. So this is the second one answer, that is copper loss, it is equals to 2050 watt. 2050 watt. Now, so according to this, we are able to calculate the total losses. So total losses, it is equals to constant loss plus copper loss, or it may be iron and friction loss plus copper losses. So iron and friction losses is nothing but 950 plus copper losses 2050. So total losses is nothing but 3000 watt. Total losses, it is nothing but 3000 loss. Total loss, it is equals to 3000 watt. Okay, getting इथपर्यंत लक्ष आलं?
Yes, sir.
Now what we want to calculate next? Output of the prime mover. Output of the prime mover means input of the generator, right? Generator's input. So for that, all of you see the power stages. So stage number 1, that is stage A. After that, there are some of the frictional losses. There are iron loss. After that, the power developed in the armature. After that, the copper loss, and the C is nothing but output. Okay, see, you are having the value of friction and windage loss, or it may be iron and friction loss, that is constant loss. You are having the value of this variable losses, that is copper loss, and you are having the value of output power. Output power ची value माहिती आहे ना? Hello.
Yes, sir.
Okay, so see, we want to calculate the output of the prime mover. Prime mover's output calculate करायचं आहे, that means input of the generator. That is A we want to find out. See, output of the prime mover, output of prime mover, it is nothing but, it is equals to input of the generator. Input of generator input, it is equals to, so power output P out plus this all losses, हे loss plus ha loss is nothing but input of the generator. P out plus total losses is nothing but 3000. किती आहे ती value? Output of the prime mover. So this is the third one answer. P out किती आहे? आपण कॅल्क्युलेट केले इनिशियली. P out is equals to 48,750 plus total losses, it is equals to 3000. Total losses काय? 3000.
51,750.
Okay, 51,750 watt. This is the output of the prime mover or the input of the generator. Question same, prime mover's output किंवा generator's input. Okay, so it is the output of the prime mover or input of the generator. So this is the third one. And now fourth one point is that calculate the efficiency, like commercial efficiency, mechanical efficiency, electrical efficiency. Tell me the formula for finding commercial efficiency according to the power stages. सांगा formula काय आहे? कमर्शियल इफिशियन्सीचा
Output divided by output plus losses.
output divided by output plus losses, right? Total losses, no?
Yes, sir.
According to these stages, whether it is C divided by A or B divided by A,
C divided by A, sir.
right? It is the C divided by A. It is nothing but commercial efficiency. Can I rub this side? Here up करू का
Yes,
मी?
sir.
Okay. See, first one we are calculating efficiency, that is commercial efficiency. It is nothing but P out divided by P in, that is input power or output of the prime mover. So it is nothing but P out is equals to 48,750 divided by 51,750 into 100. किती आहे ती व्हॅल्यू? Commercial efficiency.
Ninety-four 94.20.
94.20%. It is the commercial efficiency. Okay. Now, second one is that mechanical efficiency. Mechanical efficiency. काय formula? What is the formula for mechanical efficiency? Eta m. It is equals to whether it is B divided by A or C divided by B.
B divided by A, sir.
B divided by A. B divided by A is nothing but power developed in the armature divided by output of the prime mover or input of the generator. So you are having the value of power developed in the armature. आर्मेचर मध्ये डेव्हलप होणारी पॉवर आहे का तुमच्याकडे? फॉर्म्युला कॅल्क्युलेट केली का आपण?
Yes, sir.
किती आहे ती? बी ची व्हॅल्यू किती आहे ती व्हॅल्यू बी ची? पॉवर डेव्हलप्ड इन द आर्मेचर.
$39,000.
39,000. How? See,
Easy into IA ना.
we want to calculate this value. B ची व्हॅल्यू कॅल्क्युलेट करायचे. We are having the value of C. Also we are having the value of A. A कन्सिडर केलं, याच्यामधून जर आयर्न अँड फ्रिक्शन लॉस मायनस केले तर ही पॉवर मिळेल. किंवा सी कन्सिडर केलं
50,800, sir.
किती?
50,800.
50,800. So see, suppose I will consider the output power. Output power plus this copper loss is nothing but power developed in the armature. That is power developed in the armature. It is equals to output power 48,750 plus copper loss. Copper loss किती आहेत? 2050. It is nothing but power developed in the armature. Armature मध्ये डेव्हलप होणारी पॉवर. राईट. किती आहे ती व्हॅल्यू?
50,800.
50,800. 50,800. सिमिलरली जर आपण ए कन्सिडर केलं, दॅट मीन्स इनपुट पॉवर कन्सिडर केली. या इनपुट पॉवर मधून जर आयर्न अँड फ्रिक्शन लॉस मायनस केले तर सेम पॉवर मिळेल. सी, that is 51,750 minus 950 किती येते हे 50,800 येते ना 50,800 watt. It is the power developed in the armature, that is value of B, right? बरोबर ना?
Yes, sir.
Similarly, another one formula for finding this is nothing but EG into IA. या फॉर्म्युला आपण कॅल्क्युलेट करू शकतो ना आपण. So what is the value of EG?
Yes, sir.
254
254
into IA is nothing but 200. So again this power is nothing but 50,800. कोणत्याही मेथडनी जावा सेम येईल. So calculate the efficiency, that is B, value of B is nothing but 50,800 divided by A, that is input power of the generator 51,750 into 100. किती येईल efficiency?
98.16.
98.16, no?
Yes, sir.
Okay.
Yes, sir.
98.16%. After that, again we want to calculate the electrical efficiency, that is eta E. What is the formula for electrical efficiency? काय formula?
C upon B.
C upon B. We are having the value of C. We are having the value of B. That means output power divided by power developed in the armature. Output power का है 48,750 divided by 50,800 into 100. So this is the electrical efficiency. This one is the electrical efficiency. What is
95.96.
95.96% efficiency. Okay. So this is the important and easy question. Find out the generated EMF, then find out the copper losses, again find out the output of the prime mover, that means input of the generator. After that find out the efficiency. त्याच्यावरून परत काय करायचं, efficiency calculate करायची. Okay, getting? याच्यामध्ये काय डाऊट आहे कोणाला? Is there any doubt?
No, sir.
Mechanical efficiency 98.16 is nothing but 98.2. Electrical efficiency 95.96, so 95.9, and the overall efficiency is nothing but 94.2. Okay, getting? लक्षात आला? काय डाऊट आहे कोणाला याच्यामध्ये?
No, sir.
Okay. All of you take this example for homework. Same problem hai, little bit change in is there. See, a shunt generator has a full load current of 196 ampere at 220 volt. The stray losses are 720. So again this will be comes under the constant loss, and shunt field coil resistance is 55 ohm. If it has a full load efficiency of 88%, efficiency is given. Find the armature resistance. Armature resistance calculate करायचे, that is RA. Also find the load current corresponding to the maximum efficiency. Maximum efficiency, we have already studied about the condition for getting maximum efficiency, and we have find out one formula, that is IL is equals to, एक IL चा फॉर्म्युला आपण डिराइव केला होता. IL is equals to what this formula? Load current at which maximum efficiency it will be occur. काय फॉर्म्युला त्याचा? IL is equals to
root WC upon RA.
root WC divided by RA. Okay, so see, IL is nothing but IL is equals to constant losses divided by armature resistance. Before that, we want to find out the armature resistance. Armature resistance find केला तरच हे calculate करता येईल. First of all, calculate the armature resistance, then calculate this load current at which the maximum efficiency will be occur. Okay. All of you take this example for homework and try to solve. If you are not able to solve, then I will solve in the next lecture. Okay. In this way, we will conclude this today's lecture and we will stop here.
Sir.